Ohm's law is that current is directly proportional to the potential difference as long as the temperature remains constant. In the IV graphs, the ohmic resistor has the same potential difference and current throughout the whole of its graph. On a diode graph, the further the potential difference is on a diode, majority of the time it stays near the origin. However, all of a sudden, if it gets too negative, the current of the diode just turns dramatically negative, and it's on the other side. As the potential difference increases, the current also increases dramatically more. In a filament lamp, the rate at which the current increases as the potential decreases, although it is still increasing, it's just not increasing as much.
Ohm's law
is
a resistor whose resistance that decreases as the temperature goes up. An example of this is a sensor. A semiconductor diode is not a thermistor, but it does only let the current flow in one direction. A superconductor has zero resistance because there is no heat loss, and a superconductor has to be below critical temperature, which is negative 263 degrees Celsius. And the problem with this is it's really expensive. However, it has its uses. For example, a strong magnetic field and reduction of power loss in transmission of electrical power. A superconductor
ideal voltmeter
has infinite resistance, whereas an ideal ammeter has zero resistance. Energy equals ITV. In series, the EMF total equals the sum of EMF. However, the current total equals any current on the circuit. And in parallel, the current total equals the sum of currents, and the EMF total equals a potential difference at any point.
Kirchhoff's first law is that the total current entering a junction equals the total current leaving it. This means that charge is conserved. In Kirchhoff's second equation, the total EMF around a series circuit equals the sum of the potential difference across each component. This means energy is conserved. Kirchhoff's dividers are used to supply constant or variable potential difference from the power supply. Examples of these are LDRs and thermistors. There are two equations that you need to know. One of them is the potential difference out equals the potential difference in multiplied by the second resistor over the first resistor plus the second resistor. The second is that V1 over V2 equals R1 over R2. Also, the terminal potential difference is the amount of potential difference needed to stop the current.